Okay, now this last page of your notes is a review of when we did the cosine and sine cofunctions. I just wanted to go back and review it because you do see this quite a lot on your CDA. So let's remember complementary angles. Complementary angles are when we can add two angles together, which in our example, they would be angle A and angle C. So if I add the measurement of angle A plus the measurement of angle C, I should get 90 degrees because they are complementary angles. And that's what complementary means. So if the measurement of angle A is 30 degrees, then the measurement of angle C has to be 60 degrees because that would equal 90 degrees, okay? So when we're talking about a right triangle and we're using complementary angles, we take the right angle out, okay? If you take out the right angle, the other two angles that you see here must add to 90 degrees. And the reason why is because of the triangle sum theorem. If we add all the angles inside the triangle, we have to get 180 degrees. Well, if this one's 90, what do we have left for the other two angles? 90 degrees. Because 90 plus 90 will give me 180. Okay? So, the way that the sine and the cosine function work is the sine of one of my complementary angles will be equal to the cosine of the other angle. So, for example, right below here, I said the sine of 42 degrees equals 2 over 3. And the cosine of 48 degrees will also equal 2 over 3. Why? Because if you add 42 degrees plus 48 degrees, you get 90 degrees. Notice that they are not the same measurement. They are complementary of each other. So if you do the sine of one angle, which is 42 degrees, then you have to change it and do the cosine of the other angle. Their measurements will always be the same. And they ask you a question, several questions like this on your CDA. So I wanted to go ahead and set up some of these problems so that you can see how they look. So they say in number 1 that angle A and B are complementary angles in a right triangle. So A would be the angle that's here and B is here. So that means that C is a right angle. Now A and B have to add to they have to add to 90 degrees because that's what complementary means. Now they tell us that the tangent of A, and now they're giving me a trig ratio. So I draw my little man by A because they're talking about A as the angle, which means I'm looking from the perspective of A. Now we know that tangent equals opposite over adjacent because we use so, ka, toa in order to remember this. And remember that tangent is opposite over adjacent. And that's how we set up our ratios. Well, if I look at my picture, the opposite angle of the opposite side of A would be this side, BC. And by looking at my fraction, 7 is the opposite side. So that means this side has to equal 7. Okay? A would be adjacent, and that would be for 24. Well, I know the diagonal is the hypotenuse side. That would be H. This is the opposite side, and this would be the adjacent side. Well, by them telling me that the tangent of A is 7 over 24, they are giving you the lengths of the sides of the triangle. They're giving you two. They're giving you the opposite side, which we've already identified as 7, and the adjacent side. So this side is equal to 24. Let me move that over so it's easier to read. Alright, so the adjacent side is 24. Now that we know two sides of the triangle, okay, in order to write the cosine or the sine, we need to know what the length of the hypotenuse is. So we know two sides of this triangle and we are missing one side. What do we use whenever we need to find one of the sides of a triangle? It's not a trig function. Correct. It's Pythagorean's theorem. This is what we started out with. You are going to use Pythagorean's theorem so much on this quiz because anytime you know two sides and you're looking for the other side, that's easy. That's a squared plus b squared equals c squared. Well, we know c is the hypotenuse, so that's just going to say c because we don't know our hypotenuse. That's the diagonal side and we don't know its measurement. So A is normally the side that's standing straight up and B is normally horizontal when we're using Pythagorean's theorem. So 24 squared plus B, which is 7 squared. When we finish, remember, you have to take the square root and we get our answer. So 24 squared, I'm putting this in my calculator. 24, and then I hit the x squared button on my calculator, plus 7 squared gives me 625. Well, that's going to give me c squared and not c. I need c, so we take the square root of 625. So now I know the measurement of c because I just took the square root of both sides. And in my calculator, that means I have to hit the second and the x squared button in order to take the square root. Now that I know what c is, I can come over here to my graph, to my picture. Oh, I put white, I meant black. Okay, I'm going to plug this in right here because c is the hypotenuse. It always is the hypotenuse. Alright, so now we know the lengths of all of our sides. Okay, so that side is 25. And you have to excuse me making all these mistakes today. I don't know what's up. Okay, so now I know what my c is. Now we can answer the question. They said the value of the tangent of A is 7 over 24. And remember, they gave you that so that you could plug it into your triangle like we did to use Pythagorean's theorem and find the third side. That's why we did everything that we did. Now they say, what is the value of the cosine of B? So now I need to change my little stick figure. We're not going to be looking from the perspective of A anymore. Okay? We're going to be looking from the perspective of B. And I'm just cleaning all this stuff up because we can't use anything that we already had in there because now we changed our angle. So the little stick man goes at angle B because that's the side that we're looking at. Alright, 7 was the length that was given in the tangent. I just wrote that back in there. Alright, so cosine means that I'm looking at adjacent and hypotenuse. Well, I know this side is the hypotenuse. So I know I'm going to be using the number 25. Now, I draw a line to determine the side that is opposite. And that means the other side is adjacent. So these are the two numbers that I'm concerned with in order to answer this question. What is the value of the cosine of B? So I say the cosine of B equals adjacent, which is 7, over hypotenuse, which is 25. And we are done. Alright, so let's do the same thing. We can attempt to work this on our own. Ms. Hall, you can pause the video and let them try to work it on their own, or you can just go ahead and keep playing the video. Just depends on the class. Alright, so A and B are complementary angles in a right triangle. So that means C is the right angle. These two need to add to 180. That's what complementary means. They add to 180. Alright, once again they gave me the tangent. and we're looking at it from the perspective of angle A. They tell you the angle right after your trig function. So I'm going to draw my stick man over here. Okay? And I'm doing this so that I know where to put the number 4 and so I know where to put the number 3. So we're using SOHCAHTOA. Alright, and since this is tangent, I'm using this. So the O represents the 4 and the A will represent the 3 because tangent is opposite over adjacent. So the opposite side is 4 and the adjacent side is 3. Looking from the perspective of A. So the opposite side is 4, and I'm going to put the O here. And the adjacent side, this is my adjacent side, is 3. Now they ask you to find the cosine of B once again. So I just happen to know that triangle 3, 4, 5 is one of Pythagorean's triples. And every time you see 3 and 4, you automatically know the other side is 5, but I will prove it to you for those of you who do not understand how I got that 5. Okay? It's kind of like something that you can remember, but I'll just show you. So 5 is C, obviously, because that is the side that is across from the right angle. So that's the side we would be solving for. Alright, let me plug in the A, which is 3, and the B, which is 4. So 3 squared is 9, and 4 squared is 16. And 9 plus 16 is 25. So you could have just typed this whole thing right here in your calculator and press enter. You get 25. Now we take the square root. And everybody knows the square root of 25 is 5. So you can do the math and get it, or you can just remember that if 3 and 4 have to be the shorter sides, the hypotenuse will be 5. This 5 cannot be located anywhere else. It has to be on the hypotenuse. Alright, so now we're ready to find the cosine of B. So we know that the cosine of B is going to require me to do adjacent over hypotenuse. And I need to clear up my little letters, because every time we look at it from a different angle's point of view, we redraw our stickman. And notice we're looking at it from B now. Tangent was looking at it from A's perspective. So I draw my stickman at B, because that's what they asked me for here, was the cosine of B. And I'm looking for adjacent and hypotenuse. So I know the hypotenuse is 5. That's my H. And I can draw a line to determine the opposite side, which would be 3. So 4 is the adjacent side to angle B. Okay? So cosine of B equals the adjacent side, which is 4, divided by the hypotenuse, which is 5. So there is my cosine of B. Alright, for 3 and 4, they say angles X and Y are complementary angles in a right triangle. The value of the sine of X equals 8 over 17. Find the cosine and the tangent of X, and then find the sine, cosine, and tangent of Y. Okay? Well, we know that the sine of X equals 8 over 17. We also know that sine equals opposite over hypotenuse. That is the SO in the SOHCAHTOA. Alright, so this problem is on here for a reason, because you're going to see this on your CDA. All we're really doing is using Pythagorean's theorem to find the missing side, and then we will set up each one of our fraction ratios for our angles. Okay, so let's plug in the values that they gave us which is 8 and 17, into the triangle. Okay? So looking at it from X perspective means I draw my stick man at X because that's the angle that we're referring to. The opposite side would be 8 because SOHCAHTOA is opposite over hypotenuse. And I now know that the hypotenuse is 17. So I just need to find this other missing side, and then we're ready to write all of our ratios. Writing our ratios is the easy part. We just have to do Pythagorean's theorem, okay, to find the missing side. So remember, Pythagorean's theorem is a squared plus b squared equals c squared. Since they gave me the hypotenuse, they gave me c. So 17 goes on this side. We're solving for A because that would be the vertical piece, and B is 8. So now I just need to solve this in order to find out what A is. So 8 squared is the same thing as 8 times 8, which is 64. 17 times 17 is 289. And then I subtract 64 from both sides. That means A squared equals 225. And remember, your last step always with Pythagorean's theorem is to take the square root of both sides. This side will give me my answer. So second square root of 225 equals 15. So A is 15. Now I know that this side is 15. So once we get all the sides in here, writing our functions is easy, okay? I wanted to give you just a little bit to copy down the Pythagorean's theorem. And then we will be ready to write all of our functions. All right. So remember, we have to do the sine, cosine, and tangent of x, and then the sine, cosine, and tangent of y. Well, we already have the sine, so let's do the cosine of x. So that means we're looking at it from x perspective. Cosine is adjacent over hypotenuse. Well, we know this is the hypotenuse side, this is opposite, and this is adjacent, looking at it from x's perspective. So adjacent would be 15 over hypotenuse, which is 17. The tangent of x is opposite, 8, over adjacent, 15. Alright, now we're done with all the x's. Now let's do the y's. So all that means is that we have to redo our where we wrote our H, our O, and our A. All the numbers stay the same. We're just going to redo our letters, okay? So I'm going to erase this. I'm going to take my stick man out of here and remove the letter there and the letter there. Okay, so now the stick man is going to go down here for y because we're looking at everything from y's perspective. How do you know that? Because it says right here, do the sine, cosine, and tangent of y. That means that's the angle that you're looking at it from that perspective. Alright, looking at it from y's perspective, this is the opposite side. This is the hypotenuse always. And this is the adjacent side. Alright, so let's do our cosine. So cosine of y, cosine of y is adjacent over hypotenuse. So adjacent is 8 over hypotenuse, which is 17. And notice that we had the same thing here. So the sine of one of your angles and the cosine of the other will give you the same thing. So then we know the sine of y is going to equal what? It should be 15 over 17. So opposite, 15 over 17. Notice that these two things are exactly the same. So the tangent of y equals opposite over adjacent. So that would be 15 over 8. Alright, and that is problem number 3. So number 4 is going to require me to do the same thing. And this is the last problem that we have that's really long. 5 and 6 are very short. Okay, so we're almost done. Just stick with me. So angles x and y are complementary in a right triangle. The value of the sine of x equals 5 over 15. Now we know so, ka, toa. So since they said sine, we're looking at this one. And that means that 5 represents an opposite and 13 represents the hypotenuse. So we're looking at it from x perspective. So my little guy goes here. And we're going to label all the sides. This will be opposite because it is directly across from the man. This is hypotenuse and this is adjacent. Now I just need to write these numbers in where they belong. So 5 should go where we have opposite. And 13 should go where we have the hypotenuse. Now we just need to find this missing side and we're ready to solve the problem. So a squared plus b squared equals c squared. The hypotenuse is 13, so that goes for c every single time. And 5 is the only other number that I know, so that's b. And a squared, which is the vertical piece going straight up and down, is unknown because we don't have that number. So we solve. 25, 5 times 5 is 25. And 13 squared is 169. Okay? Then we subtract 25 on both sides. And I get 144. And we should all know that the square root of 144 is 12. So A over here is 12. Alright. Now we have all the sides done, so we're ready to go ahead and set up. They want us to find the cosine and tangent of x, and then find the sine, cosine, and tangent of y. Okay, so once we write down the cosine of x, we'll know 4 of our numbers. We just won't know the tangent of the last one. Alright, so let me clear up Pythagorean's theorem here. I hope you had it copied. If not, please get that from a neighbor, or you can go back and watch the video later. Alright, so we have sine of x because that was given to us in the beginning. That was 5 over 13. So I just copied that. Now let's do cosine of x. The cosine of x is adjacent, which is 12, over hypotenuse, which is 13. So we just use this, adjacent over hypotenuse. This side had the a on it, this side had the h on it. So I just created my fraction. And now we need to do the tangent of x. Well, the tangent is opposite over adjacent. So I'm looking for the o and the h. So the o is 5, that's opposite, and the adjacent side is 12. Alright, so now let's do the cosine. Cosine of y So that means I draw my figure down here, should be equal to 5 over 13. Because remember, sine and cosine of opposite complementary angles should be the same. The cosine, I'm sorry, we just did the cosine. The sine of y should be the same as the cosine that I had here. Sine and cosine of opposite angles should be the same. So 12 over 13. And then the tangent of y, tangent is equal to opposite, which would be 12, over adjacent, which would be 5. Alright, and that required me to change the position of my little man over here. That's why I drew him over here. So the opposite side, when we look at it from y's perspective, would be 12, and the adjacent side would be 5. So notice when we look at it from the other angle, we simply switch the A and the O. And hypotenuse is always the same. It's always the same number. Alright, so to wrap this up, number 5 and 6 just require you to put the angle measurement in here. Okay? So we know that the sine of 23 is 0.39. They're asking you, what should the angle measurement be for cosine if it is equal to the same thing? Now remember the 90-degree rule. So we have to take 90 and subtract 23 out, because that's the angle that they gave me here, and that's going to give me my angle that we're going to fill in here. So 90 minus 23 equals 67. Oh, Lord Jesus. So this one would need to be 67 degrees in order for them to be the same. Alright, now we're going to do the same thing for, the same thing for this one. So this one is 37. It's equal to 0.6. What should the cosine be so that it is the same? Well, just have to take 90 and subtract out 37. Alright, so we get 53 degrees. And that's it. Okay, I just wanted to make sure that you knew how to use the complementary angles theorem. I did this in my first lesson on Trig, and I'm doing it again in the last lesson because it is very important. Okay, so that's it for today. Thank you guys so much for paying attention. I know it was a long lesson. That's why you didn't have a warm-up. You'll have a review Monday and Tuesday and test on Wednesday and Thursday. Thank you guys.